Welcome, curious minds, to What Is, where we tackle the biggest questions, one profound query at a time. Today, oh boy, today we're tackling the biggest. Not just big in scope, but big in sheer, mind-boggling, existential awe. Today we ask, what is the universe? Now, before you reach for your philosophical dictionary or that tinfoil hat, let's be clear. This isn't a simple question with a neat, tidy answer. It's a centuries-long epic of discovery, a cosmic detective story, and honestly, a testament to humanity's stubborn refusal to simply not wonder. So buckle up, because we're about to embark on a journey that spans billions of years, light years, and more than a few fundamental misunderstandings. We'll explore what our current understanding tells us, how we stumbled and soared through historical perspectives, and where we might be headed as we peer into the grand and enigmatic future of cosmic discovery. Prepare yourselves. Your tiny speck of existence is about to get a whole lot more interesting. 1. Current understanding. So what is the universe, according to our latest, greatest scientific understanding? At its most fundamental, the universe is everything, and I truly mean everything. All of space, all of time, all matter, all energy, and the very laws and constraints that govern them. It's a vast, accelerating expanse that began with an event we call the Big Bang, roughly 13.8 billion years ago. It's not just a collection of stars, it's a cosmic web of galaxies, each containing billions or even trillions of stars, planets, gas clouds, and dark, empty spaces. Our own galaxy, the Milky Way, is just one of an estimated 2 trillion galaxies observable from Earth. That's 2 trillion with a T. Let that sink in for a moment. If you tried to count them, dedicating 1 second to each, you'd be counting for over 63,000 years. You'd better pack a lunch. And these galaxies aren't just sitting still. They're rushing away from each other, carried along by the expansion of space itself. Think of it like the dots on an inflating balloon. The dots aren't moving on the surface between them is growing. This expansion, we now know, is actually accelerating, pushing along by something truly mysterious. Enter the cosmic dark side, dark matter and dark energy. Together, these two comprise about 95% of the universe. That's 95%. All the stars, planets, you, me, everything we can see, touch, or detect with our most powerful telescopes, that's just the visible 5%. It's like arriving at a massive party and realizing you only know about 5% of the guest. The other 95% are invisible, intangible, and incredibly influential. We can't see dark matter, but we know it's there because of its gravitational effects on galaxies. It's the unseen scaffolding that holds the galactic structures together. If you want to find out more, we have a video on dark matter specifically, which will be linked above. Then there's dark energy, the ultimate cosmic enigma. This is the stuff that's driving the accelerated expansion of the universe. It's like an anti-gravitational force pushing things apart. We have no idea what it is, where it came from, or why it exists, but it's the dominant energy density in the universe. It's the biggest mystery box in the cosmos, and we're just staring at it, desperately trying to pick the lock. Our current understanding also tells us about the very early universe, thanks in large part to the cosmic microwave background, or CMB. This faint glow of radiation, detectable across the entire sky, is essentially the afterglow of the Big Bang, the oldest light in the universe. It's a baby picture of the cosmos, taken when it was just 380,000 years old. Before that, the universe was too hot and dense for light to travel freely. It was a cosmic soup. The CMB gives us incredible clues about the universe's initial conditions, its composition, and how structure began to form. So the universe as we see it today is a vast, expanding, accelerating, dark matter-filled, dark energy dominated tapestry, born from a singular event and still ringing with the echoes of its infancy. It's elegant, it's intricate, and it's profoundly humbling. And the best part? We're only just beginning to truly grasp its incredible complexity. 2. Historical perspective, evolving ideas. But how did we get here? From staring at the stars with wide-eyed wonder to mapping the cosmic microwave background. It wasn't a straight path, let me tell you. It was more like a winding, often confusing, occasionally hilarious, but ultimately triumphant journey of evolving ideas. For most of human history, the universe was a much simpler, albeit more self-important, place. The prevailing view for thousands of years was that Earth was the center of everything. We were clearly special, right? The sun, the moon, the stars, all revolved around us. It made sense from a purely observational standpoint. Everything looks like it's orbiting Earth. The ancient Babylonians, for instance, saw the cosmos as a series of nested spheres, with Earth in the middle. The ancient Greeks, particularly figures like Ptolemy around the 2nd century AD, refined this geocentric model into a sophisticated system of epicycles and deferents to explain the seemingly erratic movements of planets. It was a mathematical marvel that worked surprisingly well for predicting planetary positions, even if it was fundamentally wrong about the cosmic address. It was like building an incredibly complex Rube Goldberg machine to make toast, when all you really needed was a toaster. But hey, it made sense to them, and it stuck around for over 1,400 years. Talk about stubborn. Then came the scientific revolution, and things started to get a little less self-centered. In the 16th century, a Polish astronomer named Nicholas Copernicus proposed the radical idea. Maybe the sun, not the Earth, was at the center of the solar system. The heliocentric model was born. It was simpler, more elegant, and explained planetary motion far better. But it was also controversial. It challenged the deep ingrained religious and philosophical beliefs. Enter Galileo Galilei in the early 17th century, who with his improved telescope provided observational evidence that supported Copernicus. He saw moons orbiting Jupiter, phases of Venus like those of our moon, and craters on the moon. These observations directly contradicted the idea of perfect celestial spheres orbiting Earth. His discoveries got him into a bit of trouble, to put it mildly. But the cosmic cat was out of the bag. Isaac Newton, later that century, then provided the mathematical framework for this new universe with his laws of motion and universal gravitation. Suddenly, the heavens and Earth were governed by the same set of predictable laws. Gravity explained why apples fell and why planets orbited. The universe was still finite, a sort of clockwork mechanism, but it was vast and governed by elegant principles. For a long time, our galaxy, the Milky Way, was thought to be the entire universe, until the early 20th century, that is. Turns out, we were still thinking a bit small. This brings us to the monumental contributions of Albert Einstein. In the early 1900s, his theories of special and general relativity revolutionized our understanding of space, time, gravity, and the universe itself. Gravity wasn't just a force, it was the curvature in the fabric of space-time caused by mass and energy. This opened up entirely new ways to think about the universe dynamically. Einstein himself initially added a cosmological constant to his equations to force the universe to be static, as this was the prevailing belief. He later called this his biggest blunder, when evidence for an expanding universe emerged. Even the super geniuses can make mistakes. And that evidence largely came from Edwin Hubble in the 1920s. Using powerful telescopes, Hubble observed distant nebulae, thought to be gas clouds within our galaxy, and realized they were actually other galaxies far, far away. He also noticed that the light from these galaxies was redshifted, meaning they were moving away from us, and the further away they were, the faster they were receding. This was the observational proof of an expanded universe. The idea of a static island universe was shattered. This expansion led to the development of the Big Bang theory. Georges Lemaitre, a Belgian priest and physicist, first proposed the idea of a primeval atom, or cosmic egg, that exploded. Later, George Gamow and his colleagues developed the theory further, predicting the existence of the cosmic microwave background radiation. And guess what? In 1964, Arno Penzias and Robert Wilson, while trying to troubleshoot a pesky noise in their antenna at Bell Labs, accidentally discovered this very CMB radiation. They thought it was just pigeon droppings or faulty equipment, but it was actually the faint, uniform glow from the universe's infancy. This serendipitous discovery provided powerful evidence for the Big Bang and marked a turning point in modern cosmology. We had found the cosmic baby picture. So in just a few thousand years, humanity's understanding of the universe evolved from an Earth-centered celestial sphere to the sun-centered clockwork, then to a galaxy as universe model, and finally to the vast, expanding cosmos born from a hot, dense state. It's a tale of constant revision, challenging assumptions, and embracing the unexpected. It proves that our current understanding, while robust, is just another step in this incredible intellectual journey. 3. The future. Alright, so we've peeked into the past, celebrated the present, and now we must gaze into the future. What mysteries remain? What questions will future generations of scientists grapple with as they continue humanity's grand cosmic quest? The truth is, despite our incredible leaps in understanding, our knowledge of the universe is still remarkably incomplete. Remember that 95% of the universe composed of dark matter and dark energy? Yeah, that's our biggest blind spot. Understanding these enigmatic components is the holy grail of modern cosmology and particle physics. What are they? Are they new particles, modifications to gravity, or something even more bizarre that we haven't even conceived of yet? The future will bring new experiments, new detectors like the Large Hadron Collider, looking for dark matter particles, or next-generation observatories mapping the universe with unprecedented precision to understand dark energy's influence. Another profound question: what happened before the Big Bang? Or is before even a meaningful concept when time itself is thought to have begun with the Big Bang? This touches on theories like the cyclic universe, where our universe might just be one in an endless series of expansions and contractions, or the multiverse theory, which suggests our universe is merely one bubble in a foam of countless others. These are speculative, yes, but they represent the cutting edge of theoretical physics, pushing the boundaries of what we can even imagine. And of course, the age-old question that continues to captivate us all: are we alone? Is there life beyond Earth? With the discovery of thousands of exoplanets, planets orbiting other stars, the odds seem increasingly high. Future telescopes, like the James Webb Space Telescope, are already beginning to analyze the atmospheres of these distant worlds for biosignatures, chemical indicators of life. Imagine the day when we confirm microbial life on another planet, or even dare to dream, detect signals of intelligent civilizations. That would fundamentally alter our understanding of our place in the cosmos. Then there's the ultimate fate of the universe. What will happen in billions, trillions, or even quadrillions of years? Will it continue to expand indefinitely, eventually fizzing out in a heat death, where all the energy is evenly distributed and nothing more can happen? Will dark energy tear apart galaxies, stars, and even atoms in a big rip? Or, less likely given current data, will it reverse course and collapse back in on itself in a big crunch? Our understanding of dark energy will dictate our final cosmic chapter. The scientific tools of the future will be astonishing. We're building gravitational wave observatories like LIGO and soon LISA, which don't just see light, but hear the ripples in space-time caused by cataclysmic events like colliding black holes. This opens up an entirely new window into the universe, allowing us to observe phenomena that are invisible to traditional telescopes. We are developing AI and machine learning to sift through the unimaginable amounts of data we collect, finding patterns and anomalies that the human eyes might miss. The future of understanding the universe isn't about finding answers, it's about asking better questions. It's about building bigger, more sensitive instruments. It's about fostering collaboration across disciplines and cultures. It's about nurturing that fundamental human curiosity that has driven us from staring at campfires to launching telescopes into space. The universe is a story that's still being written, and we as a species are both eager readers and active participants. We are tiny beings on a small blue planet, yet we possess the capacity to ponder the infinite, to decode the cosmos, and to marvel at its profound beauty and complexity. And that, in itself, is perhaps the greatest wonder of all. So what is the universe? It's everything we know, everything we don't, and everything we've yet to imagine. It's a journey from ancient myths to quantum gravity, from geocentric certainty to cosmic humility. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. From the visible matter of stars and planets to the elusive dark matter and dark energy that dominate its fabric, from the fiery birth of the Big Bang to its uncertain future, the universe is a living, breathing, constantly evolving mystery, and we are incredibly fortunate to be here now to witness and participate in its unfolding story. Thank you for joining us on this incredible cosmic adventure. If this journey through space and time has left you with even more questions, or perhaps a renewed sense of awe, then we've done our job. Don't forget to like this video, subscribe to What Is for more deep dives into the perplexing, the profound, and the absolutely fascinating. And let us know in the comments, what aspects of the universe do you find most mind-blowing? We love to hear your thoughts. Until next time, keep looking up and keep asking what is, and keep exploring the boundless wonders of our amazing universe. See you next time.